Hello, space enthusiasts, and welcome back to our channel. Today, we re-diving deep into the cosmos to talk about a fascinating visitor from beyond our solar system, Interstellar Comet 3IATLAS. What is this mysterious object, and what secrets does it hold about the universe? Let's find out together. First, let's break down the name. 3IATLAS. The 3I tells us it's the third interstellar object ever confirmed. The I stands for interstellar, meaning it originated from outside our solar system, from the vast emptiness between the stars. The Atlas part comes from the system that discovered it, the Asteroid Terrestrial Impact Last Alert System in South Africa. This powerful survey scans the sky for near-Earth objects, but sometimes it stumbles upon something truly extraordinary, like a traveler from another star system. So, when did we first spot this cosmic wanderer? 3IATLAS was discovered on January 22nd, 2024. Astronomers immediately noticed something peculiar about its path. Unlike comets from our own Oort cloud, which orbit our sun, this object was on a hyperbolic trajectory. Imagine throwing a ball so fast it escapes Earth's gravity entirely. That's essentially what 3IATLAS is doing with our sun. It's moving too quickly to be captured by the sun's gravity, which is the smoking gun for its interstellar origin. It's just passing through, giving us a brief, precious window to study it. But what makes this comet so special, besides its origin? It's the composition. Early observations suggest that 3IATLAS is what we call a water-rich comet. As it gets closer to the sun, the ice on its surface sublimates sterns directly from solid to gas, creating a beautiful coma or atmosphere around its nucleus. By studying the light that passes through this coma, scientists can determine what it's made of. And in this case, the signature of water is strong. This is incredibly exciting because it tells us that water, the key ingredient for life as we know it, isn't just common in our solar system. It's likely abundant in other star systems too. This supports the idea that the building blocks of life could be delivered to planets all across the galaxy by comets, just like this one. Think about it. This comet might have formed in a planetary system light years away. It could have been ejected from its home star's orbit by a gravitational nudge from a giant planet, much like Jupiter sometimes flings objects out of our own solar system. For millions, maybe even billions of years, it has traveled through the cold, dark void of interstellar space. And now, by a stroke of cosmic luck, its path has intersected with ours. It's a pristine sample from another corner of the Milky Way, delivered right to our celestial doorstep. Now, you might be thinking of our other interstellar visitors, Oumuamua, 1I, and Borisov, 2I. How does Atlas compare? Oumuamua was an enigma-strange, elongated object that showed no cometary activity. Borisov, on the other hand, looked and behaved much like the comets from our own solar system. 3IATLAS seems to fall into the Borisov camp, appearing as a more classic comet. However, there's a key difference. Atlas appears to have a much higher ratio of carbon monoxide to water than Borisov did. This variation is crucial. It suggests that the chemistry of protoplanetary disksta, nurseries where comets and planets are born, can vary significantly from one star system to another. Each interstellar object gives us another data point, helping us piece together the grand puzzle of how planetary systems form and evolve across the galaxy. Let's talk about the journey of 3IATLAS. After its discovery, it continued its inbound trip toward the Sun. Its closest approach to the Sun, called perihelion, is predicted to happen in late 2024. This is the moment astronomers are eagerly awaiting. As the comet gets blasted by intense solar radiation, it will light up spectacularly. More material will be vaporized from its surface, allowing our telescopes, like the James Webb Space Telescope, to get an even clearer look at its chemical makeup. We'll be searching for complex organic molecules, the carbon-based compounds that are the precursors to life. Finding these would be a monumental discovery, strengthening the theory of panspermia, the idea that life can be seeded across the universe. However, there's a dramatic possibility. Comets are fragile objects, often described as dirty snowballs. The intense heat and gravitational forces near the Sun can cause them to break apart. We've seen this happen with many comets from our own solar system. Will 3IATLAS survive its fiery encounter with our star? Or will it disintegrate into a cloud of dust and gas? Either outcome is scientifically valuable. If it survives, we can track it as it heads back out into interstellar space. If it breaks apart, the freshly exposed interior material will give us an unprecedented view of its pristine primordial composition, material that hasn't seen the light of day since it formed around a distant star. The discovery of 3IATLAS also highlights just how much our technology has advanced. With projects like the ATLAS survey and the upcoming Vera-C Rubin Observatory, we're scanning the sky with more precision than ever before. We're no longer just passively waiting for these objects to appear. We are actively hunting for them. Scientists now estimate that several interstellar objects likely pass through our solar system every year, but most are too small or too faint to be detected. With each new discovery, we refine our models and get better at predicting where to look. We are entering a new era of interstellar astronomy where we can begin to statistically study the population of these wanderers. What does the future hold for the study of objects like 3IATLAS? Imagine a future mission, a high-speed probe designed to intercept an interstellar comet. This is no longer science fiction. Engineers at NASA and other space agencies are already designing concepts for such a mission. A spacecraft could fly through the comet's coma, directly sampling the gas and dust. It could even potentially land on the nucleus, analyzing its surface up close. Such a mission would provide ground truth data that telescopes simply cannot. It would be like having a sample return mission from another star system without having to travel light years to get there. The story of 3IATLAS is a profound reminder of our place in the cosmos. We live in a dynamic, interconnected galaxy. Objects are constantly being exchanged between star systems, carrying with them the chemical clues of their origin. Each interstellar visitor is a message in a bottle, a time capsule that has traveled across unimaginable distances and timescales. By studying them, we learn not just about other star systems, but about our own origins as well. Was the water in Earth's oceans delivered by comets? Did the organic molecules that sparked life arrive on an interstellar traveler billions of years ago? These are the grand questions that 3IATLAS is helping us answer. So, as we continue to track this incredible object on its journey through our solar system, we stand on the brink of new discoveries. It's a testament to human curiosity and our relentless drive to explore the unknown. From a faint blip on a screen to a key piece in the puzzle of our cosmic origins, 3IATLAS is more than just a comet. It's a bridge to the stars. Thank you so much for joining me on this cosmic journey today. What do you think is the most exciting thing about 3IATLAS? Let me know in the comments below. And if you enjoyed this video and want to stay updated on the latest space discoveries, make sure to hit that like button and subscribe to the channel. We'll see you in the next video.